Hello, Mrs. O'Donnell here. Today we are factoring special products. All right, so our goals for today are to factor the difference of two squares and factor perfect square trinomials. Make sure you're logging in to Google Classroom each day to check and see what it is you need to do. The agenda will be updated with all the video links and the forms on Monday. All right, so let's recall factoring to find our zeros, right? So last week we learned about factoring trinomials, and we specifically were practicing using this box method where we said, okay, my factors are what goes on the outside, right? Because I know to find the area inside a box, I would multiply my length and my width. Okay, so if this is representing the area inside of my box, I've got p squared plus some numbers and 10. And I know this diagonal here is going to add to make that 11p. I don't totally know how it's going to break down just yet, but I know it's going to add to make 11p. Well, this can help me to start the factoring process, right? I know in order to make p squared, I have to have p times p. In order to make 10, I have a couple of options, right? I could multiply 1 and 10 or 2 and 5. 2 times 5 makes 10. So I have to try and think which one of those options is going to land me with an 11p. Well, it looks like probably the 1 and the 10. So I'm going to pop a 1 and a 10 on there, and I'm going to test it out to make sure that it actually worked, right? So p times 10, that gives me 10p, and p times 1 gives me 1p, and if I add those together, I would get that 11p. So my final answer here for my factored form would be p plus 1 times p plus 10, and so that would be my factored form. And if I want to solve to find my zeros, I know I can just set that equals 0, and I can think about that zero product property, right? So what number, if I plugged it in here, would make this factor 0, making the entire polynomial 0, and that would be p equals -1. And then also what number plugged in for p here would make this factor 0, that would be -10. So my zeros are at -1 and -10. Okay, so now we're refreshed on how to factor. Let's look at some special cases. So here, you might recognize this. We've talked about these special cases already, but maybe you don't recognize it, and that's okay. We want to think, how can I still factor this x squared minus 9 using my box method when I'm only being given two terms here? Well, remember, we can always rewrite our polynomial in standard form, which means we have those descending exponents. So x squared plus 0x to the first power minus 9 would be another way of writing this polynomial. Well, so that being said, I can fill in my box. I know that this top one's going to be my x squared. I've got this minus 9 down here, and my diagonal is going to add to make 0x. Okay, so now I can start doing some factoring. So let's see here. My x squared is pretty straightforward. I know x times x is going to make that x squared. But now I have to think about my factors of -9. So let's see here. I've got 1 and -9, -1 and +9, and 3 and -3, or -3 and 3, which are really the same factors. So I want to think which one of those pairs is going to hopefully get me to that 0x. And hopefully at this point you see, we're going to want that 3 and that -3. So if I have a 3 here, put my -3 here, and then of course I want to check my thoughts. So -3 times x, that gives me -3x. 3 times x here gives me 3x. If I add those together, I've got 0 x's, and voila. So my final factored form would be x plus 3 times x minus 3. or I guess I could write that up here, x plus 3 and x minus 3 would be the equivalent expression. If I want to solve it for my zeros, I just set the whole thing equal to 0, and I figure out, okay, what number, when I plug it in for x to this first factor, will make that factor 0, right? Using that zero product property. So I know if I plug in a negative 3 for my first x, that's going to make my entire thing go to 0. And same thing for my second x here. If I plug in a positive 3, that's going to make that entire polynomial go to 0. If it's hard for you to see that right off the bat, you can always set each individual factor equal to 0 and solve, right? X plus 3 equals 0, and then use those inverse operations. X equals negative 3, right? X minus 3 equals 0. Use that inverse operation. X equals 3. Okay. So now the more that you work with these special cases, the more comfortable you'll get with them, and the more quickly you'll recognize the special factors, right? So again, if you want, if you don't recognize this difference of two perfect squares right off the bat, you can always write it in standard form, filling in that missing value with a 0, a coefficient of 0, right? And then you're filling it in here, right? 36x squared, you've got your minus 25, right? This is equal to 0x on the diagonal. Now this one's a little trickier because we've got this leading coefficient of 36, but still hopefully not too bad, right? I know, and we've already said that this is a difference of two perfect squares. So hopefully at this point you're starting to recognize, hey, 6x times 6x is going to give me 36x squared. 5 times 5 is going to give me that negative, or that 25, and I have to make one of them negative. And when I do that, right, check out, check your work. 6x times negative 5, well, that gives us negative 30x. 6x times 5, that gives us 30x. And when you combine those like terms, add them together, you get 0x's, right? So voila, we found our factor pairs. 6x minus 5 times 6x plus 5. Okay, now of course, if you want to memorize the rule, right, you're taking the square root of your first term minus the square root of your second term, and the square root of your first term plus the square root of your second term. You could very easily memorize this pattern to solve it more quickly. It's a little trickier if you want to solve for to find the zeros. 6x minus 5 times 6x plus 5 equals 0. You want to set each one of your factors equal to 0 and solve to find what x is, right? So use SADMAP, those inverse operations. I'm going to add 5 to both sides. So 6x equals 5. Divide by 6 to both sides of my equal sign. So I've got x equals 5 over 6. And then I'm going to do the same thing over here to this factor pair. So I'm going to subtract 5 from both sides. 6x equals negative 5. I'm going to divide by 6 to both sides of my equal sign. So x equals negative 5, 6. So 5, 6 and negative 5, 6 would be my zeros for this problem. All right, well, so that was our difference of two perfect squares. Now we have our perfect square trinomial. Again, you can solve this just like you've been solving, right? Fill in x squared. We know our diagonal is going to make the 8x, and 16 goes in the bottom square. And then hopefully once you've got that stuff filled in, if you recognize the pattern, it's going to go, your factoring is going to go really quick, right? X times x makes x squared. 16, that's 4 times 4, right? And you can check it by going through. X times 4 is 4x. 4 times x is 4x. When you add those together, you get your 8x. And so I know that my factor pair is going to be x plus 4 times x plus 4, or I could even write it shorter as x plus 4 quantity squared. Okay, if I want to solve to find my 0, right? I only have one factor really here, so I am only going to have 1 0, and that's just asking x plus 4 squared, set it equal to 0. So what number, when I plug it in for x, is going to make that whole thing go to 0? That's going to be a -4 in this case. All right, and now we've got another one. Hopefully, again, you're recognizing, hey, I've got a perfect square in the front, a perfect square in the caboose, and probably 2 times the first time times the last to get me to the end there, right? Maybe this isn't a perfect square trinomial. Let's check this one out, right? So we've got 4x squared. We've got our plus 1, right? So I know, okay, and then I know my diagonal has to add to make -4x. All right, so let's see here. We may have to do a little bit of guess and check here. If I have 2x times 2x, and I have 1 times 1, or maybe -1 times -1, that would give me a perfect square, right? So let's see here. 2x times -1, that gives me a -2x, and 2x times -1 gives me a -2x, and -2x plus -2x, yep, that made my -4x, so it worked out. So I've got this perfect square trinomial, and I know my factor pairs end up being 2x minus 1 times 2x minus 1, or the shortened version, which is 2x minus 1 quantity squared. If I want to solve for my zeros, remember the zeros are those x-intercepts. We often call them the solution. Sometimes they're even called the roots to our quadratics. So you'll just take that factored form, 2x minus 1 times 2x minus 1, set it equal to 0, and solve, right? So 2x minus 1 equals 0. I'm going to use my inverse operations here. So I've got 2x equals 1, divide both sides by 2, x equals 1/2. Okay, and I only have to do it one time here because my factors are identical. I only have 1 0. There's only one root for perfect square trinomial. Okay. And that's all I've got for you today, so please make sure that you fill out your Google form to get your attendance and participation credit. Thanks so much. Come to office hours if you have questions.